finding the HCF and LCM of two numbers. HCF represents highest common factor, and LCM is short for lowest common multiple. Let's now find out the HCF and LCM of two numbers, say 20 and 30. As I've shown you before, we need to break this down into prime factors. 2 and 10, of course 2 is a prime number, 10 is 2 and 5, both prime numbers. So 20 equal 2 times 2 times 5. And 30 here, 2 and 15, 3 and 5. So I'm going to list prime factors of 30 underneath of 20. So 2 times 3 times 5. Now, in order to find the HCF, I'm trying to find the common factors. So here we have a 2 in common. We also have a 5 in common. So the HCF is 10. Means 10 is the biggest number that 20 and 30 can get divided by. No number bigger than 10 can fit in 20 and 30 at the same time. That is called the highest common factor. Now, for the LCM, we need the same prime numbers which we decomposed. Here I want to find the LCM. That means if I write the multiples of 20, 20, 40, 60, 80, 100, and so on. And if I wrote multiples of 30, let me just continue with here, 120, and here. You can see 60 is the first common multiple. But there are other common multiples. The other one is 120 and could be more and more. But 60 is the lowest common multiple. But that's one method of listing. But using method of prime factor decomposition, the LCM would be asking ourselves, what are the numbers that form the prime factor decomposition? The digits are 2, 3, and 5. We don't have anything except 2, 3, and 5. So which line offered more 2? The top line. offer 2 2s compared. So I will be using 2 2s. Then the other digit is 3. There's 1 3 here and no 3 there. So 1 3 is the maximum number of 3s. The next digit is 5. 1 5 here, 1 5 here. So the maximum number of 5 is just 1 5. No line can offer more than 1 5. And then we work this out. 2 times 2, 4. 4 times 3, 12. And 12 times 5, 60. Which we found here. So 60 is my LCM. More examples of HCF and LCM. So in this example, find HCF and LCM of 16 and 40. So first we need to go on to the prime factor decompositions. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. Go to 40 now. Any two numbers comes to give me 40. 2 and 20. 2 and 10. 2 and 5. So let's list them now. 16 equal 2 times 2 times 2 times 2. And 40 would be 3 2s times together times 5. Let's go for the HCF. The highest common factor. There is a 2 in common. There is another 2 in common. And finally another 2 in common. So 2 times 2 times 2 is 8. 16 and 40 can both be divided by 8, the biggest number. 8 is the biggest number that can fit into 16 and into 40. Now, let me relist these prime factors in order to find the LCM. For the LCM, look at the number of digits we have here. The only digits are 2 and 5. Which line offers more 2s? Top line offers 4 2s, the bottom one offers 3 2s. So I take the maximum number of 2s that a line offers me. That would be 4 lots of 2s here. 5, no 5 here, 1 5 here. So the maximum number of 5 is just 1. So the LCM would be 5 times 2, 10, 20, 40, 80. So 80 is the lowest common multiple, which you can always check by the other method. Write multiples of 16. 1 16, 2 16, 3 16, 4 16, 4 16, 64, 5 16, 80, and so on. And multiples of 40, 140, 240. You can see 80 is the first number which is common in both lines. So 80 is the smallest or the lowest common multiple. One more example, finding the HCF and LCM of 14 and 35. 14 is 2 times 7. They're both prime numbers. 35, 5 times 7. They're both prime numbers. So 14 is 2 times 7. And 35 is 5 times 7. So HCF is the number or numbers which are common in both lines. You can see that the only common number is 7. So HCF of 14 and 35 is 7. Let's write this again for LCM. So for the LCM, we look at the number of digits we have. We have digit 2, digit 5, and digit 7. Which line offers me more 2's? Top line with only 1 2. 5, the maximum number of 5 is in the second line, and there's only 1 5. Both lines offer 7, but the maximum number of 7 is 1. 1 7 here, 1 7 here. So I take 1 as the maximum number of 7. And when you multiply, 2 times 5, 10, times 7, 70. That's the LCM. If you list the numbers, you could have seen this as well. Multiples of 14, 28, 42, 56, 70, 84, and multiples of 35, 135, 235, which again give you the same value of 70, which is the smallest common multiple of these two numbers. Okay, so I think you've had enough examples on finding HCF and LCM based on factor decomposition. I hope you've enjoyed it. We can use LCM to find the smallest common denominator for adding and subtracting fractions. And there are, of course, the other uses which we will go through in future lessons. So thank you very much and see you soon.